Hello, and welcome to channel What Destroyed the Indus Valley Civilization? The 3rd millennium BC saw a high concentration of urban development across several continents. Small settlements began expanding into sophisticated, densely populated regional hubs. By the year 2200 BC, human civilization had hit a remarkable stride across the globe. Early empires were thriving, supported by booming agricultural systems and rapidly growing. During its mature phase, the Indus Valley Civilization established a massive footprint across northwestern South as its inhabitants constructed expansive cities like Mohenjo-Daro and Harappa. Archaeological remains show a high degree of architectural precision. The Harappans utilized standardized brick sizes, grid-based town planning, and complex drainage networks servicing entire neighborhoods.
Neighborhoods in Egypt's Old Kingdom and Mesopotamia's Akkadian Empire commanded enough wealth and centralized labor to construct massive permanent monuments to their own power. Then, starting around 1900 BC, these urban centers were abandoned. Within a few generations, the population exited, leaving the streets empty and the infrastructure silent. Early historical models attributed this disappearance to conflict. The assumption was that the peaceful cities fell to an influx of steppe pastoralists or farmers migrating from the west, but within a few decades, these seemingly invincible states fractured. Your account within 3 business days.
In Mesopotamia, agricultural plains were abandoned as thousands of refugees fled south. In Egypt, severe famines shattered the centralized government. No invading army conquered both Abe's empires at the same time. The simultaneous collapse was driven from the inside out by a shared environmental failure. In 2019, a genetic analysis of the Rocky Gari site provided a new context for this transition. Researchers successfully sequenced an ancient genome that redirected the narrative of Harappan origins. The data came from a skeleton labeled individual I-6113. This individual was excavated from a cemetery located approximately 1 kilometer west of the ancient town. The DNA profile revealed a distinct lineage.
Harappans were an indigenous mixture of ancient Iranian-related lineages and Southeast Asian groups. In individual I-6113, steppe pastoralist ancestry was absent. This contradicts the theory that the civilization was replaced by a migration from the west. With the invasion model removed, the cause for the urban abandonment remains. If the cities were not emptied by an external military force, a different catalyst drove the population out of their metropolises. Evidence of social fracturing appears simultaneously in several disparate regions. Geologists trace this destruction to a severe long-term drought roughly 4,200 years ago. The shift was so intense that it officially marks the boundary of our current geological age, the Megalian. Yet the outcome of this global event was anything but uniform. While some sprawling empires turned to dust, other human populations managed to pivot and persist. The survival rates vary so wildly from region to region that modern scientists actually debate whether this period should be considered a simultaneous worldwide catastrophe. The trigger is a significant slowdown of the AMOC, a massive system of ocean currents regulating global temperatures. When it weakened, it pushed the intertropical convergence zone, the Earth's main tropical rain belt, drastically southward, pulling moisture away from agricultural zones. Researchers can track exactly when this happened by reading physical environmental records. High in the mountains of Western Canada and Iceland, ice cores reveal a period of highly anomalous glacial growth. Meanwhile, deep underground, chemical signatures of severe multi-decadal dry spells are permanently locked into the slow-growing layers of stalagmites in places like Italy and India. These physical proxies offer concrete proof of an extended, severe climatic disruption. The environment changed rapidly, putting immediate pressure on the human populations that depended on it.
415. The Akkadian Empire and Egypt's Old Kingdom were the wealthiest states on Earth, but they shared a critical vulnerability. Their entire existence relied on the predictable flooding of a single water source, the Tigris and Euphrates, or the Nile. When the rains failed, stream flows dropped precipitously. Prolonged dust storms choked the Middle East, and crop yields collapsed, triggering widespread, unmanageable famines. The highly centralized political structures of these empires were designed for administration, not agility. They simply could not redistribute resources fast enough to handle sudden, severe scarcity. When these systems are built entirely around a single fixed water source, they lose the ability to absorb shocks of this magnitude. Further east, the Indus Valley Civilization offered a very different response. As rains faltered, major urban centers like Mohenjo-Daro were systematically abandoned in a strategic retreat. The weakening monsoon caused the Gagar-Hakra river system to dry up entirely. Instead of starving in place, the Harappan people picked up and migrated eastward toward the more reliable rains of the Ganges basin. This is a chart modeling annual weather data and crop seasons for the Indus region. It shows how the Harappans survived by diversifying their agriculture, shifting away from water-heavy winter crops like wheat and planting drought-resistant summer millets. Modern genetic analysis reveals that as these displaced populations moved, they intersected and merged with migrating Indo-European speakers entering India. At the same time, the Indus response demonstrates that decentralization, mobility, and cultural integration are incredibly effective strategies for surviving extreme environmental stress. On the Iberian Peninsula, populations hit by the drought took a different approach entirely. Instead of migrating horizontally across the map, they dug straight down. They engineered structures known as motilas, intricate circular stone fortresses built deep into the earth. These served as the oldest known complex groundwater collection systems explicitly designed to reach the dropping water tables. The environmental pressure forced a shift in engineering, moving from river dependency to a system of active groundwater extraction. Today, however, the 4.2 kiloyear event is the subject of intense debate among paleoclimatologists. Many doubt that it was a uniform global megadrought. The skeptics point out that while proxy data confirms extreme aridity in Mesopotamia and Egypt, sediment records from central China and the Alps actually show an increase in rainfall. Because of this, some researchers conclude that the event is actually a collection of localized, unsynchronized climate shifts, rather than a single simultaneous catastrophe. But this geographical unevenness is exactly what creates the illusion of a scattered historical record.
The climate shifted globally, but the local weather effects and the human responses were wildly different. Whether you view the 4.2 kiloyear event as one massive drought or a series of localized falling dominoes, the historical lesson remains exactly the same. Highly centralized, rigid societies, no matter how wealthy or monumentally powerful, are consistently the most vulnerable to sudden environmental shifts. The 4.2 kiloyear event functioned as a selective filter, pushing human societies toward new strategies for survival. When the Earth's climate abruptly changes, inflexible systems inevitably break. But adaptable populations find ways to survive by moving, integrating with new cultures, and inventing new ways to reach the water. The Indus Valley's decline was part of a larger pattern of instability across the globe. In Egypt, the Old Kingdom fell apart following a series of exceptionally low Nile floods. 813. The resulting famine dismantled the centralized government. During this same window, the Akkadian Empire in Mesopotamia crumbled, and Neolithic cultures across central China vanished from the archaeological record. Today, paleoclimatologists identify these synchronized events as the 4.2 kiloyear event, a severe, long-term aridification that impacted the entire northern hemisphere. This instability began with a significant weakening of the Atlantic meridional overturning circulation. As ocean currents slowed, global precipitation patterns were disrupted. The tropical rain belt abruptly shifted southward. For northern agricultural societies, the seasonal rains they relied on for centuries simply stopped arriving. The collapse of these early states was less a political failure and more a consequence of a multi-century atmospheric shift. We can reconstruct this ancient environment using geological proxies, physical materials recording past climate conditions. 917. In Mesopotamia, sediment records show massive spikes in dust flux, and these layers indicate an era of intense, prolonged aridity lasting for over 200 years. Ice cores from western Canada to the Kilimanjaro Glacier show concurrent evidence of cooling.
glaciers advanced as temperatures dropped and moisture disappeared from the atmosphere. In India, oxygen isotopes in cave stalagmites captured the decline. The chemical signatures prove the summer monsoons weakened significantly during this exact century. These geological records allow us to pinpoint the specific decade the regional water systems failed. Mapping these climate shifts onto the Indus Valley shows the direct impact on Harappan survival. Their cities were built in high density along these specific river networks. The Gagar-Hakra system was rain-fed. Crop stability and the survival of urban populations were entirely dependent on the predictability of the monsoons. As the monsoons failed, the water supply diminished.
This caused the rivers to retract toward the Himalayan foothills, leaving the lower agricultural plains parched. Without reliable floods to support large-scale inundation agriculture, the cities could no longer generate the surplus calories required to sustain their populations. The Harappan metropolises were not destroyed by an army. They were slowly emptied by a drought that lasted for 2 centuries. In the historical record, civilizational collapse is often a process of forced decentralization. The population responds to environmental stress by reorganizing into smaller units. The Harappans survived by migrating. They abandoned their urban centers and scattered toward the east and southeast, moving into regions where the shifting monsoons still provided enough water for survival. This 4.2 kiloyear event was so globally significant that it defines the start of our current geological epoch. Geologists call this the Megalion Age. The empty streets of the Indus Valley illustrate a recurring pattern in human history. When the environment shifts and the local climate fails, the primary mechanism for survival is migration.